Okay, so the next thing we're going to look at here has to do with the inverse functions, right? Such as arc sine, arc cosine, and whatnot. And so whether it says arc cosine or arc sine, same thing as this notation. Those are the same thing, right? And so this is just the inverse, meaning it undoes what was done before. So if I talk about the cosine of pi over 6, you should know that that's equal to root 3 over 2. So if I was to take the inverse of that, right, the inverse undoes it. So the inverse, the arc cosine of root 3 over 2 will equal pi over 6. So you see these are just undoing each other. The sine of pi over 4 is equal to root 2 over 2. So the arc sine of root 2 over 2 will equal pi over 4. Now, we want to kind of be careful here, because if we're thinking about the coordinate plane, I know that pi over 4 will give me root 2 over 2, but I also know that 3 pi over 4 will also give me root 2 over 2. So how do I know that the arc sine of root 2 over 2 is really pi over 4 and not 3 pi over 4? And that's where those limitations come in terms of the domain of these inverse functions. So cosine is limited to the first and second quadrant, and sine is limited to the first and fourth quadrant. So when we're talking about arc sine, this doesn't exist. These are the only two that exist, and down here, sine this reference angle of pi over 4 is negative pi over 4, which would give me a negative root 2 over 2. And that's how we kind of take care of that ambiguity, is by limiting the domain to these arc sines and arc cosines, right? And the same thing also exists. You can kind of think about, there's like 3 of these, right? So cosine and sine. Then there's one for cotangent and tangent. And there's one for cosecant and secant. So it's secant up top and cosecant going down. So sine, tangent always follows sine, and cosecant is a reciprocal of sine, so it has the same domain. Cosine, cotangent, secant. Alright, so you kind of need to memorize these to understand these types of problems. So just go through and knowing that chart, right? Knowing your 0, pi over 6, pi over 4, pi over 3, and pi over 2. Your sine, 0, 1/2, root 2 over 2, root 3 over 2, and root 2 over 2, or root 4 over 2, which is 1, right? You should know this, and if you know this, all of these arc cosine and arc tangent equations are much easier. So let's look at some of these that look a little more complicated, such as the cosine of the arc tan of 1/2. And you're going to think inside out, right? So tangent, the arc tan of 1/2 is a little tricky because the 1/2 doesn't refer to one of your special angles, right? So you're going to need to think about the tangent. Remember, tangent exists in the first and fourth quadrant. Since it's positive, it has to be in the first quadrant. So if we were to draw a triangle here, right, and here's theta. So 1/2, this is sine over cosine, or y over x. So this is a 1 and this is a 2. And you're going to have to find your radius, right? So the radius is equal to 1 squared plus 2 squared will equal radius squared. So that's going to give me 1 plus 4. So your radius is root 5. So what would give me 1/2? What gives me 1/2 here is theta, right? So this becomes cosine of theta equals cosine of theta is adjacent over hypotenuse, which is 2 over root 5. So this whole thing reduces to 2 over root 5. Okay? And if we're going to look at something like the next one here, this was number 16. We're looking at number 17, where it's cosine of arctan of -3 over 4. Alright, so again, tangent exists in first and fourth quadrant. Since it's negative, has to be down here. So again, this is y over x, so -3 over 4. So this is a 3, 4, 5 triangle, right? 3 squared plus 4 squared equals 5 squared. So this is 5. So again, this is theta. All this means, if we work our way backwards, right, the tangent of -1 doesn't matter what that actual angle measure is, which is what you would need to find to answer this inside, right? The inside would give you the angle measure, but you don't care what the angle measure is. What you care about is what the triangle ratios are, because that's what this is asking you for. So again, cosine of theta, which doesn't matter what theta is, would be the adjacent over the hypotenuse, or 4 over 5. And that would be your final answer, 4 over 5. Right? So when they're not giving you those special angles, you're going to have to draw right triangles and work your way backward from there. Alright? So again, don't worry too much about the notation, the difference between writing arc cosine or arc sine or cosine to the -1. It's all just reciprocals. And then don't worry about finding what these actual angle measures are, right? I don't care what the tangent of -1 of 1/2 is. It's going to be some angle, and it doesn't matter what it is, because you're just going to find the cosine of that angle, which just gives you the ratio back. So with these types of problems, create your right triangles, find your third side, and then find your ratio, and then solve the problem. And that's the final answer. All right? I can do one more example of those, and what we're going to look at here is number 24. Looks a little difficult, and these just keep seeming to be cosines. So cosine of arc sine of x minus h. Can't even read what that says. I can't do this one because I don't know what it means. Let's just, I don't know what that says. So let's go back to, we'll do cosecant. CSC of arc tan of -5 over 12. So again, it's another tangent function, which is negative. So draw my right triangle here. We have a -5 and a 12. So this is a 5, 12, 13. Again, Pythagorean theorem if you don't know your triples. But that's that. So that gets me theta. So now I'm thinking cosecant of theta equals, and again cosecant is the reciprocal, which is 1 over sine of theta. So sine of theta, right? Sine of theta, this would be, sine is opposite over hypotenuse, right? So this would be hypotenuse over opposite, or 13 over -5, -13 over 5. So again, hopefully this is a good, helpful, useful video to understanding what these are. Other than that, you're going to have to figure out what was going on with his handwriting, and just do the Pythagorean theorem with your triangles. That should help figure out everything else you're doing. All right? Have a good day.